welcome to Noble of Chemistry. Today we are going to start the chapter, it is coordination compounds, right? இப்போ coordination compounds எதுக்கு எப்படி நேம் வந்தது அப்படின்னு பார்த்தோம் அப்படின்னா, say for example simple salt எடுத்துக்கிறோம். If it is magnesium chloride that is dissolved in a water, that is will be dissociated as magnesium 2 plus and 2Cl minus. Okay, right. Suppose இது ஒரு coordination compounds எடுத்துக்கிறோம். Say example NH3 hexa aqua cobalt, then that is Cl2 dichloride வெளில இருக்கு. That is dissolved in a water, that is will be dissociated as cobalt hexaamine cobalt 2 plus, then outside la 2Cl minus. Okay, so say for example இப்ப வேற complex இருக்கு NH3 4 times Cl2, then that will be dissolved in a water, that is will be dissociated as NH3 and tetra aqua dichloro cobaltate and plus 2Cl minus. ஓகேங்களா? So அப்ப இந்த complexல this will not be dissociated. ஓகேங்களா? So while dissolved in a water, simple salt எடுங்க, that is dissolved in a water, that will be dissociated as a magnesium 2 plus and 2Cl minus, and if this is the salt, அப்ப என்ன இருக்கும், dissolved in a water, that will be dissociated as hexaamine cobalt 2 plus, உள்ள இருக்கிற எந்த அமைன்ஸும் dissociate ஆகல, central metal ion B central metal அப்படியே தான் இருக்கு, that is not be separated as plus and minus, அதுலயும் பாருங்க that is not be dissociated. அப்ப இந்த complex it is not be dissociated, it is coordinated together. Okay, so this complex is called as a coordination chemistry. என்ன பண்ணாலும் that is not be dissociated, it is coordinated together, so this compound it is called as a coordination compounds, right? First Verner கொடுத்திருக்கார், first it is a coordination compound discovered by Verner Theory. எப்படி வந்திருக்குன்னு பார்க்கலாம். So first it is Verner Theory. Okay, according to Verner, first treatment of Verner, say for example like this complex CO3 and Cl3, then it is 6NH3. So suppose and Verner taken as a 1 mole of cobalt chloride and hexaamine, 1 mole of cobalt chloride and hexaamine, and it is reaction with that silver nitrate. So in this first complex we will get it as a 3 mole of silver chloride. Get. Okay, right. Suppose then another compound as COCl3 dot 5NH3. That it is reaction with the silver nitrate, and to the formation of the complex as it is that, and how many moles of silver chloride will be precipitate means, in this case it is the 2 mole of silver chloride it will be precipitated. 2 mole of silver chloride will be obtained. Suppose another compounds, then 1 mole of COCl3 dot 4NH3. In the complex that is again I treated with the silver nitrate, and I will get it as Verner get it is a compound as 1 mole of silver chloride as a precipitate. Okay, so but in this complex same reagent only reacted, we will get it as a different number of moles of silver chloride. அப்ப different number of moles of silver chloride கிடைச்சிருக்கு அப்படின்னா in the counter ion, அப்ப in this complex அப்ப all the 3 chloride will be precipitated. In this complex only it is a 2 chloride as a precipitated as a silver chloride. In this compound 1 mole of silver chloride as a precipitated. So from this data Verner find out that from using this formation of the precipitate, so Verner producing the one compound, that compound is called as a coordination compound. So in this compound 3 mole silver chloride we obtain now, so that my complex it is maybe it is amine hexaamine, then in outside and 3 chloride as the counter ion in the first complex. In the second complex it is a 2 mole of silver chloride will be obtained, so this complex it is maybe it is NH3 pentaamine Cl, then and only 2 chlorine as a counter ion. Okay, because we will get it as a 2 mole of silver chloride, 2 moles 2 chloride as a counter ion. And in this complex, in pentaamine, tetraamine, here it is tetraamine, 4 ammonia, so tetraamine, Cl2. So here 1 mole of silver chloride as a precipitate, and in outside it is that 1 mole of only 1 chloride as a counter ion. So by using this formation of the precipitated, we will get it as a different number of chloride be present as a counter ion. Okay, so by using the conductivity study, this is by using the precipitation study. Then next Werner find out in the conductivity study, and using the conductivity study. By using conductivity study, Werner find out from this first complex that will be, it is dissociated as CO, NH3, 6 times, right, and cobalt, and 3 Cl minus means, and the complex getting 3 plus. Okay, so here it is 1 ion, here it is a 3 ion, and we will get it as electrolyte type. It is 1:3 electrolyte, 1:3 electrolyte. But in the second complex, and based on this conductivity, this will be dissociated as CO, NH3, 5 times, then Cl, then outside 2 Cl minus ion, 2 Cl minus, so here it is 2 plus. 2 Cl minus, here it is 2 ion, and here it is 1 ion. Totally it is that 1:2 electrolyte, 1:2 electrolyte. Right. அடுத்தது பாத்தீங்க அப்படின்னா, so in this complex it is hexaamine, sorry, pentaamine, tetraamine, Cl2, then complex மேல charge 1 Cl minus, here 1 plus. ஓகேங்களா, அப்ப the counter ion it is that in study it is that here it is 1:1, so that electrolyte it is 1:1 electrolyte. Okay, so in the first case it is 1:3 electrolyte, and second case 1:2 electrolyte, third case it is 1:1 electrolyte. Appo here in the first case totally there are the 4 ions will be present. In the second case totally presence of the 3 ion, and third case totally presence of the 2 ion. How they question they are asking means, so look at here, and இப்படி ஒரு காம்ப்ளெக்ஸ் கொடுத்துட்டு இப்படி ஒரு காம்பவுண்ட் கொடுத்துட்டு they are asking to suppose இந்த இது கொடுத்துட்டு சரியா, then this mole of precipitate will be obtained means what is the complex formation, what is the structure of the complex அப்படினு கேட்கலாம். that we have to frame. இந்த காம்ப்ளெக்ஸோட நாம என்ன பண்ணிருக்கணும், ஸ்ட்ரக்சரை ஃப்ரேம் பண்ணணும். with the help of this silver chloride ஓட precipitate யூஸ் பண்ணிட்டு the complex ஓட ஸ்ட்ரக்சரை ஃப்ரேம் பண்ணணும். ரைட்டுங்களா, அடுத்தது பாத்தீங்க அப்படின்னா, by using how many number of ions are present in the complex அப்படின்னு கேக்குறாங்க அப்படின்னா, so இப்போ வெளியில இருக்கிற கவுண்டர் அயான் மட்டும்தான் நம்ம சார்ஜ் எடுக்கணும். அப்ப எவ்வளவு நம்பர் ஆஃப் கவுண்டர் அயான் இருக்கு, 3 Cl minus. அப்ப டெஃபினெட்லி the complex மேல 3 plus இருக்கும். அதே மாதிரி தான் இந்த அப்ப எவ்வளவு நம்பர் ஆஃப் அயான்ஸ், here it is 3 ion, here it is 1 ion, totally it is a 4 ion be present. அதே மாதிரி இந்த கேஸ்ல 2 ions, இங்க 1 ion, அப்ப டோட்டலா 3 ions will be present. So like this they are asking the question, how many number of ions are present in the complex அப்படின்னு கேட்பாங்க. இல்ல அப்படின்னா இந்த காம்ப்ளெக்ஸ் கொடுத்துட்டு what type of electrolytes அப்படின்னு questions கேட்பாங்க. So you have to read like this, அந்த அளவுக்கு தரவா ரீட் பண்ணிருக்கணும் மோஸ்ட்லி. so இந்த காம்பவுண்ட கொடுத்துட்டு இவ்ளோ moles of silver chloride precipitate ஆயிருக்குன்னா what it is a complex அப்படி கேட்கறதுக்கு mostly chances இருக்கு. you just concentrate more area on this part, particular part. next Werner postulates. Werner's postulates. இதுல first பாத்தீங்க அப்படின்னா, this according to Werner theory, then according to Werner theory, that is there are 2 valencies. So one it is the primary valency, other one it is a secondary valency. Primary valency and secondary valency. So primary valency is nothing but it is or non-ionizable. Primary valency or ionizable. ionizable, primary valency or ionizable. So that primary valency, it is satisfied only by negative ion. It is that only by, it is satisfied only by negative ions. Keep it in your mind, only it is that negative ion. Okay, so this primary valency equal to oxidation number of the central metal atom. Appo what it is the oxidation number of central metal atom? That is equal to primary valency. Primary valency equal to oxidation number of the central metal atom. Oxidation number of central metal atom. This is the primary valency. Central metal atom. ஓகேங்களா, ரைட். ஸோ அடுத்து பார்த்தீங்க அப்படின்னா செகண்டரி வேலன்சி. செகண்ட் ஒன் செகண்டரி வேலன்சி. செகண்டரி வேலன்சி. Secondary valency. Secondary valency, all the secondary valency are non-ionizable. 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 Secondary valency or non-ionizable. That is are satisfied by negative ions as well as in the neutral ligands. Okay, that is satisfied by negative ions and neutral ligands ஓகேங்களா. so the secondary valency எதுக்கு ஈக்குவலா இருக்கும் அப்படின்னா the secondary valency that is equal to coordination number of the complex. ஓகேங்களா, that is equal to coordination number of the complex. Coordination number of the complex. Coordination number equal to coordination number. ஓகேங்களா, then next one, mostly in the primary and secondary valency now question கேட்பாங்க. say for example in this problem, இப்ப பாருங்க இந்த example எடுத்துக்கோங்க, and they are asking to find out in the what is the primary valency and what is the secondary valency of the complex அப்படின்னு கேட்கலாம். அப்ப இந்த கேசஸ்ல பாருங்க, that is I told that is satisfied by negative ion சொல்லியிருக்கேன். ஓகேங்களா, primary valency or ionizable, satisfied by negative ion, oxidation number of the central metal atom. say for example you just taken this example, இந்த example எடுத்துக்கோங்க. ஓகேங்களா, right. in this example, that is how many coordination number of this complex? It is a coordination number, it is 6. so upper secondary valency also will be 6. upper coordination number it will be 6, secondary valency also will be 6 in this case. Then next primary valency, I told primary valency will be ionizable and it is satisfied by negative ion. Here it is 2 number of negative ions will be there, that is equal to oxidation number of the central metal atom. So look at here how to calculating the oxidation number means, here it is X, then this is the neutral ligand, so plus 0, here it is negative ligand, 2 negative ligand, so upper minus 2, in the charge minus 1, so here it is plus 1 which is equal to plus 1, so upper X which is equal to plus 3. so upper primary valency which is equal to 3. okay, so they are asking to find out the problem. so in the mari complex கொடுத்துட்டு find out in the secondary valency of the complex and the primary valency of the complex ன்னு கேட்டாங்கன்னா you have to choose this that like this. ஓகேங்களா, ரைட். அடுத்தது பாத்தீங்க அப்படின்னா next one, the topic, the secondary valency how will be arranged. ஓகேங்களா, that is secondary valency, it is that arranged the spatial arrangement in the complex. அப்போ for example like this complex means that is a polyhedral, polyhedral. in this spatial arrangement, but my secondary valency of the complex will be 6 means how it will be arranged in the polyhedral means that is arranged in that in octahedral complex. Upper coordination number 6 means it is belonging to octahedral complex. Octahedral. If it is coordination number 5 means that is belonging to trigonal bipyramidal geometry. Trigonal bipyramidal geometry. Then if it is coordination number will be 4 means that is a 2 possibility will be there. In some of the time will be obtained as a square planar complex. Sometimes will be obtained as a tetrahedral complex. Tetrahedral. ஓகேங்களா, அப்போ that is I will explain and after upcoming topics. Okay, when will be getting the square planar complex, when we will get it is a tetrahedral complex, that and all we explain in the upcoming topics. Okay, secondary valency based on the spatial arrangement in the system. Okay, so again repeat again, in Verner's phosphate the primary valency ionizable இருக்கும், negative ions இருக்கும், that is it is equal to oxidation number of the central metal atom, and secondary valency should be non-ionizable, then negative or neutral Ligon, that should be equal to coordination number of the central metal atom. Okay, secondary valency, how it will be arranged in the spatial arrangement means that is equal to based on the coordination number. If it is coordination number 6 means it formation of octahedral, 5 means trigonal bipyramidal, 4 means square planar or tetrahedral complex. Next move on to the next topic. Suppose in the paranga. So in this we are discussed the topic no. So from this topic, how the questions they are asking. Okay, la? So this is the questions. Okay, this is the question. How many number of ions present per mole of the complex? So then in this case here it is 2 minus, and because 2 Cl no. Okay, la? Upper 2 Cl minus then plus. So upper here it is 2 number of ion, here it is 1 number of ion. So here it is 3 ions. Okay, in this case here minus, upper here plus, upper total number of ions will be 2. In this case both are will be the complex. Okay, so this is the positive complex and this is the negative complex. Totally number of ions will be 2. So number of ions it is 2 per mole of the system. And here also it's Cl minus and here it is plus, and totally 2 number of ions will be there, and so number of ions in this case it is 2. Okay, so like this they are asking. So இந்த மாதிரி complex கொடுத்துட்டு they are given as a complex, they are asking to find out in the number of ions present in the complex. This is the way to calculate it. Another possibility way, find out the secondary valency in this complex. They given the data, this is all the data it is given in a question paper, and they are asking to find out in the and secondary valency. Okay, I told that is a secondary valency equal to coordination number. So here how many moles of silver chloride will be precipitated? 1 mole only precipitated. Now we can write the complex only one chloride as a counter ion, remaining chloride ion we will be arranged in the complex itself. Okay, up to the formation of the complex NCCl2, then NH3, then 4 times, then only one chloride as a counter ion, because we will got only one chloride as a precipitate, silver chloride precipitate, so only one chloride outer side. Upon the secondary valency equal to, here it is 4, here it is 2, totally it is will be 6, coordination number 6, so that is equal to secondary valency. So in the second example, here 2 moles of silver chloride will be precipitated. Look at here complex, in palladium dichloride tetramine, 2 chloride will be precipitated. So my complex will be palladium NH3 4 times, 4 times, and 2 chloride ion as a counter ion, because we will get it is that N2 silver chloride precipitate, so that 2 chloride as a counter ion. Look at here, how many amine will be there? 4. Upper secondary valency will be 4. Secondary valency will be 4. Okay, and in this case, third case, here it is 2 silver chloride will be precipitated. Upper from by using this complex nickel and H2O 6 times, hexa aqua nickel. Okay, and 2 chloride as a counter ion, 2 chloride as a counter ion. So the secondary valency 6 molecule precipitate ஆயிருக்கு, 6 molecule water இருக்கு. So secondary valency becomes 6. And move on to the next example. Here it is 4 chlorine, here it is 2 chlorine. It is 0 moles of chloride will be precipitate. No chloride will be in the outside. Upon my complex will be Cl4, then HCl and twice. ஓகேங்களா, so இந்த மாதிரி எனக்கு present ஆயிருக்கு. Here it is 4, here it is 2. அப்ப totally my secondary valency it is 6 as a secondary valency. And the last example, here also 0 mole of silver chloride will be precipitated. அப்போ 2 chlorine இருக்கு. அப்போ எல்லா chlorine உள்ள எழுதுங்க. So that my complex Cl2 and NH3 and twice, and so that we will get it is that, and here it is 2 and in this chlorine will be 2. Appa totally is coordination number 4. Upper secondary valency will be 4. This is the method of calculating. They are asking to find out in that complex கொடுத்துட்டு இந்த மாதிரி compounds கொடுத்துட்டு and number of moles of silver chloride கொடுத்துட்டு they are asking to find out in the secondary valency means like this we have to calculate it. That's next topic. The next topic, it is and terminology in the coordination complex. What are the main terminology in the coordination complex? Okay. The first is central metal atom and ligands. Central metal atom. Okay, central metal atom. First we discussed the central metal atom. It is a atom or ion. It is bonded with the group of atoms, group of atoms or molecules, in the coordination entity, that we called as a entity, a central metal atom. So for example, an atom or ion, it is bonded with the group of atom. Okay, so say for example in this this is the cobalt, that is cobalt, it is bonded with the group of atom. So this is the group of atom. Okay, so bond up ஆயிருக்குன்னா this will be the central metal atom. Okay, so cobalt, right, look at here, this bonded with the, so cobalt bonded with the group of atom. So this is the group of atom, and so this is that in the cobalt it is act as a central metal atom. Okay, one example. Another example, so that is nickel tetrachloride N2 minus. Okay, this is the atom ion that is bonded with the group of atom. Okay, upon nickel as a center, that is bonded with the group of atom, Cl. So it is bonded with the group of atom. So this will be the nickel will be the central metal atom. Okay, then next one, ligan. That is the direct opposite. This is central metal atom bonded with the group of atom. A group of atom directly bonded with the central metal atom, that's we called as a ligands. Okay, idhile explain pannidala. And this is the central metal atom means this is the group of atom, that is we called as a ligands. Okay, this is called as ligands. Okay, in this case, and chlorine will be the ligand. ஓகேங்களா, இப்போ லிகாண்ட்ல நிறைய டைப்ஸ் இருக்கு. that is that unidentate ligand. ஓகேங்களா, so unidentate ligand so unidentate ligand means only one donor atom. Uni means one, only one donor atom are present in the complex, that is we called as a unidentate. Only one donor atom present in the complex, that is we called as unidentate. Example, okay, example, and NH3, so only one donor atom. Okay, so one donor atom, it is able to donating the one pair of electron, 2 electron, that is the one pair of electron. It is able to donating the one pair of electron. Okay, here it is ammonia, it is able to donating the one pair of electron. Say for example, aqua H2O, here it is able to donating the one pair of electron. It is cyanide, that is able to donating the one pair of electron. Unidentate ligand, it is able to, that is only one donor site, that is able to donate the one pair of electron. Next one, bidentate ligand. bidentate ligand. Okay, same. It is a two donor atom present in the complex. Two donor atom or in two donor atom. One donor atom na two electron, one pair of na. Here it is two pair of electron will be donated. Two pair of electron. Say for example, in this case, bidentate that is COO minus, then COO minus oxalate. Here it is in here this oxygen as the donor atom, this oxygen as the donor atom. Upper this is two donor atom. It is able to donating the two pair of electron. Totally four electron it is able to donate. Then adhe mari like ethylene diamine NH2, here also CH2 NH2 ethylene diamine. So here it is in ethylene amine, this able to donating the pair of electron. So this is also bidentate ligand. So next is tridentate ligand. In a சில example bidentate in a சில example பாருங்க, that is in glycinate CH2 NH2 then COO minus glycinate, that is also bidentate. Here it is nitrogen as the donor atom, here it is oxygen as the donor atom. So like this அதே மாதிரி bipredyl nitrogen bonded with nitrogen. Okay, so this is also bidentate ligand, bipredyl. Okay, here one nitrogen, here one nitrogen, bipredyl as a and bidentate ligand. Then 1,10 phenanthroline. So look at here. Here is the first question. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 10. Okay, so 1, 10 phenanthroline or phen kudupanga. Phenanthroline. That is also it is a bidentate ligand. Okay, these are that it containing two donor atom. This is these example belonging to bidentate ligand. Next it is a tridentate ligand. Tridentate ligand. Tridentate. Upper how many donor atom? Three donor atom. So it contains a three donor atom present in the ligand. So that is three pair of electron it is donated by the ligand. Three pair of electron. Okay, example it is that in triethylene. See, look at here. It is ethylene di. Here it is NH2 and here it is NH, then CH2 and twice NH2. So look at here one donor atom, இது ஒரு donor atom, here one donor, here it is one donor. அப்ப three donor atoms are present, it is diethylene triamine. ஓகேங்களா, டைன்னு சொல்லலாம். This is called as in diethylene diamine. So this is simply written as diene. That is the meaning of diethylene triamine. Diethylene triamine. Triethylene triamine. The next one it is that four donor atom tetradentate ligand. Tetradentate. So it contains four donor atom. Okay, that is that four donor atom. So it is able to donating the four pair of electron. Four pair of electron. Say example, it is ethylene, CH2, NH2, then it is NH, then CH2 twice, NH, then CH2 twice, then NH2. So here it is how many donor atom it is there? Here it is 1, here it is 2, this is N ma. This is N. Okay, 2, then here it is 3, here it is 4. Upper in this complex, in this ligand, it is 4 donor atoms, so it is belonging to tetradentate ligand. அதே மாதிரி 5, that is a pentadentate ligand. இதுல 6 donor atom இருக்கிறது complex, 6 donor atom. Next is hexadentate ligand. So in this 6th donor atom, So it is able to donating 6 pair of electron. 6 pair of electron. 6 pair of electron. Example பாருங்க ethylene diamine tetraacetic acid. Look at here ethylene diamine. இப்படி எழுதுவோமா ethylene diamine. இல்ல hydrogen replace பண்ணிட்டு you have to substituting the acetate. அப்போ here it is substitute CH2 COO minus. Here also CH2 COO minus acetate tetraacetate CH2 COO minus. Here it is CH2 COO minus. Okay, see, look at ethylene diamine tetraacetic acid. Okay, that is we called as EDTA. EDTA. That is ethylene diamine tetraacetic acid. Next, this is that about types of ligands. It is over. So next after completing the terminology, what is positive ligand, what is negative ligand, what is neutral ligand, that and all we completed. Okay. So the next one, it is that oxidation number. Oxidation number. Oxidation number. That is a method of calculating the oxidation number. So ஒரு complex கொடுத்திருக்காங்க அப்படினா in tetramine Cl2 complex N3 plus. Find out the oxidation number of this complex. Okay, not 3 plus. And here also Cl2. Okay, appo find out the oxidation number of this complex means here it is 2Cl minus. Okay, appo here it is 2 plus. Appo the complex it is X plus 0 minus 2 which is equal to plus 2. That is not possible. Look at here. In the case la idu possible illa. Right, Cl minus appa plus 1 Cl. Okay, plus 1. Okay, appa in the complex here it is minus 1. Appa in the complex mele plus 1. The oxidation number, if idoda oxidation number calculate pannu X. This amine it is the neutral ligand plus 0. Then chloride is the negative ligand minus 2 which is equal to plus 1. Okay, appa X which is equal to plus 3. So in the here it is X which is equal to plus 3 oxidation number. This is the oxidation. This is the method of calculating oxidation number. Okay, right. Then next one it is and oxidation number coordination number calculation. That is already I told you. That is coordination number of this complex. Here it is 4. Here it is 2. The coordination number of this complex it is 6. Okay, this is and all basic terminology. This will be over. The next step is naming the complex. Before naming the complex, we have to first find out in the positive ligand, negative ligand, and neutral ligand. Okay, right. So before naming the complex, we can it is negative ligand. List out in the negative ligands. Negative ligands. Negative ligands. So negative ligand Cn minus. So we used as the name it is cyanido. Earlier days எப்படி இருந்ததுன்னா cyanone இருந்தது. இப்போ என்னவா யூஸ் பண்ணிருக்காங்கன்னா cyanido. Then next பாத்தீங்க அப்படின்னா it is hydroxido. 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 Okay. Then it is that NO2 minus nitrito N. Nitrito N. Nitrito N. Okay, the next one it is that oxalato C2O4 2 minus oxalato then SO4 2 minus that is we written as sulfato then CO3 2 minus that is we called as carbonato then it is O2 2 minus it is peroxo that is O2 minus it is oxo then so this most probably that are all negative ligands then in glyoxum NHCH3 then CH double bond NOH then single bond CH CH3 and double bond NO minus. ஓகேங்களா, glyoxim, dimethyl glyoxim, simply we denoted as DMG, dimethyl glyoxim, dimethyl glyoxim, glyoxim. This is also negative ligand. ஓகேங்களா, mostly this is used as a negative ligand. Then halogens எல்லாமே பாத்தீங்க அப்படின்னா it is halo. Okay, simply it is denoted as halo. That is chlorine இருந்தது அப்படின்னா chlorido, chlorido. bromine இருக்கு அப்படின்னா that is bromido, bromido. Okay, like this. So iodine is iodo, fluorine in the fluorido. Like this we can name the yeah, ligands, right? Next one, it is that neutral ligand, neutral ligand, neutral ligand. So neutral ligand H2O, that is aqua, that is a special name, aqua. Okay, that is NH3 amine. We should use as amine ku 2 m use பண்ணனும், amine NH3. No, we not use the ammonia, water அப்படிலாம் யூஸ் பண்ணக்கூடாது. At H2O used as aqua and NH3 used as amine, we called as amine. ஓகேங்களா, then in neutral ligands ல பாத்தீங்கன்னா ethylene diamine, it is a neutral ligand, that is simply denoted as En, ethylene diamine, ethylene diamine. And phosphine neutral ligand, phosphine PH3, that is neutral ligand. And triphenyl phosphine, triphenyl phosphine, that is that. And triphenyl, like this, triphenyl phosphine, there is a also neutral ligand. Okay, then once again,